The Tanque Argentino Mediano, or TAM, has, since the early 80s, equipped the forces of the Ejército Argentino, the Argentinian Army. Designed and developed by the West German company of Thyssen-Henschel, the TAM's history is full of inconsistencies and exaggerations, primarily the fact that it is an Argentinian indigenous tank. While some important components have been produced in Argentina and most assembly took place there, too much of it is dependent on foreign companies to consider it fully indigenous. Argentina had remained neutral during most of World War II. Although it declared war on Germany and Japan in March 1945, the country had previously held strong sympathies towards Germany. On June 4, 1943, a coup took place which, in time, gave rise to Colonel Juan Domingo Perón, the most divisive character in Argentinian history, who became the country's president in 1946. Perón would be overthrown by a military coup in 1955. For the following 2 decades, there were several other military coups stagnating Argentina. In military terms, Argentina had a large army. Taking advantage of the end of World War II and the availability of a large stock of surplus and extremely cheap US and British armored vehicles, Argentina became a considerable military power in the region. Between 1946 and 1949, Argentina purchased or acquired at least 250 universal carriers, around 400 Shermans, 18 Crusader II gun tractor Mark I, 6 M7 Priests, and 320 M-series half-tracks. By the mid-1960s, these vehicles were becoming obsolete and needed replacing. Tensions with the USA following the 1966 military coup meant that the purchase of a large number of M41 Walker Bulldogs failed, leading Argentinian military officials to launch Plan Europa in 1967. Led by General Eduardo Uriburu, the intention of this plan was to modernize and diversify Argentina's armored vehicles with the purchase of European vehicles. The ultimate goal, however, was to avoid dependence on any foreign power to provide armor vehicles. As set out by the Estado Mayor General del Ejército, General Staff of the Army, the plan would be not only to acquire vehicles, but also the license to produce them in Argentina. Before the end of the decade, the purchase of 80 AMX-13s armed with a 105mm gun, 180 AMX VCI armored personnel carriers, 14 AMX 155F3s, and 2 AMX-13 PDP Model 51s from France, and around 60 or 80 Morvag Grenadier and possibly a number of Morvag Roland from Switzerland was agreed. Additionally, 60 Morvag Rolands and 40 AMX-13s were assembled under license in Argentina. Despite this, none of these vehicles were sufficiently powerful to replace the Sherman Firefly as the main tank for the Argentinian forces. During the trips to Europe, the AMX-30 and Leopard 1 were studied and considered, but for whatever reason, negotiations for their purchase were not continued. In 1973, and still without a tank, the General Staff got serious and outlined the requirements for a medium tank to equip Argentinian forces from the 1980s onwards. Potencia de fuego, movilidad y protección. Firepower, mobility, and protection were the 3 main basic criteria determined by the General Staff for this new tank in 1973. In a document, they established the requirement priorities: a modern cannon of at least 105mm, secondary armament consisting of 2 machine guns and smoke dischargers, integrated automatic fire control system, over 500 km range, 70 km per hour speeds on roads, a power-to-weight ratio of 20 horsepower per ton, a weight under 30 tons, a low silhouette, nuclear, biological, and chemical warfare protection, and a crew of 3 or 4. The low weight needed for the new tank was determined by the existing infrastructure. A heavy tank would not fare well on the roads and bridges of the likely deployment areas, in the south and along the border with Chile, so weight had to be limited. Additionally, the rail network though extensive, was quite old and again would not have been able to carry heavy vehicles. At the end of 1979, the Logistic Headquarters 4 of the General Staff, following the set requirements, created the Proyecto de Tanque Argentino Mediano, Argentinian Medium Tank Project, which set out to study the feasibility of designing and developing the new tank. They soon found out that a project of this magnitude and with such strict requirements could not be developed in Argentina. Argentina had very limited know-how of the development of tanks, having only previously built the Nahuel in 1943 and done some minor to major modifications of British and US vehicles, but this was another matter altogether. In 1974, the Argentinian Ministry of National Defense reached an agreement for co-production and technology sharing with the West German company Thyssen-Henschel. Thyssen-Henschel, with the participation of Argentinian technicians, would design the tank based on the General Staff's requirements, build 3 prototypes, including one for the Vehículo de Combate Transporte de Personal, and carry out the construction of a pre-production series and of the production series in Argentina. It was agreed by both parties that, for ease of production, speed of development, and, presumably, cost, it was best to base the new vehicle on pre-existing and tested technology. To that end, the Marder infantry fighting vehicle, which equipped the West German Army, was chosen as the basis for the new vehicles. The following 2 years were dedicated to the design and development of the TAM, until September 1976, when the first prototype was completed, followed by the second in January 1977. The prototype for the VCTP was finalized in 1977. The vehicles were tested at the Thyssen-Henschel facilities before the VCTP and at least one of the TAMs was sent to Argentina for further testing and evaluation under the supervision of the General Staff. Thyssen-Henschel would keep one of the prototypes and improve it with more expensive equipment. This vehicle, the TH-301, was intended for the export market, but unfortunately for the West German company, it was unable to find any additional customers. It is very important to establish that the TH-301 was not a prototype of the TAM, as many sources state, but rather a development of the TAM prototype by Thyssen-Henschel. Over the next 2 years, the VCTP and TAM drove almost 10,000 kilometers over all the types of terrain and in all the climates found in Argentina. For context, Argentina has a very varied geography: mountainous and very high peaks in the west, arid deserts across the middle at all lengths of the country, wetlands in the northeast, and polar tundra in the south. The final assessment by the General Staff was satisfactory, and it authorized the series production of the TAM, though it recommended a total of 1,450 modifications. Whilst trials were taking place, the General Staff ordered the construction, though this was most likely more of an assembly job, of 4 more prototypes, 2 TAMs and 2 VCTP, in the General San Martin and Rio Tinto factories, to carry out more tests and evaluate the factory's capacities before production of the serial version. Although designed abroad, the whole idea the General Staff had in mind was to be able to produce, or at least assemble, the new tank in Argentina. So a whole new infrastructure had to be created, incorporating state-run enterprises and also private companies. Arms factories were repurposed to produce the TAM components to be developed in Argentina, with General San Martin factory building the hulls and Rio Tercero factory building the turrets and armament. The Argentinian company Bator Cookies S.A. also produced the torsion bars and rubber pads. However, many components were still produced in West Germany or other countries, with several different companies working on different elements, including Feinmechanische Werke Mainz on the electro-hydraulic system for gun stabilizer, Motoren- und Turbinen-Union on the engine, Renk for the transmission, Diehl for tracks, Standard Electric Lorenz for the communications, AEG Telefunken for the fire control system, Carl Zeiss for the optics, Tensa, Bertolina, Pescarmone and Fiat for some elements of the undercarriage. In all, according to Mazzarasa and Sigalfagliani, by 1983, 70% of all TAM components were produced in Argentina. In March 1980, with the objective of having one company that would coordinate the whole TAM program, the Tanque Argentino Mediano Sociedad del Estado, or TAMSE, was created. TAMSE was established as the main contractor of the TAM NVCTP and given the task of overseeing the final assembly, delivery integration of the tanks into the army, trials, homogenization of the optics and armament, and potential exports. TAMSE was given a 9,600 square meters covered assembly plant in Boulogne-sur-Mer, just outside Buenos Aires. The installations at Boulogne-sur-Mer also housed 2 warehouses to stock vehicle components, offices, laboratories for quality control evaluation, engine test benches, a pit for trials, and a shooting range. Production had begun beforehand in April 1979, with components coming from West Germany and assembly taking place in already existing factories. The initial order was for 200 TAM and 312 VCTP, though this number would not initially be fulfilled. The TAM is simply a modified Marder IFV hull with a turret, meant to occupy the role of a medium tank or light main battle tank. Thus, externally, in appearance and design, they are very similar. The frontal plate is at a pronounced 75-degree angle, and the sides and rear plates are positioned at 32 degrees. The turret is rear-mounted. The sides have several attachments for tools, spare tracks, spare machine gun ammunition, water cans, medical kits, and various other ancillary equipment. At the front of the tank, on each side, are headlights. Behind these, also on each side, are wing mirrors. Some early TAM prototypes retained the side skirts of the Marder 1, but these were removed on the series TAM. The TAM's armor is made out of electrically welded nickel-chromium molybdenum steel. The front plate is 50 mm thick and the sides and rear 35 mm. With such feeble armor, the tank's best protection is its speed, mobility, and low silhouette. Additionally, the TAM is equipped with an Nbc Protection System, allowing the crew to operate in a contaminated area for up to 8 hours. The Nbc system feeds the main and driver's compartments with filtered air that can absorb solid or gaseous elements from poisonous or radioactive substances. The vehicle is able to operate in very harsh temperatures, from as low as minus 35 degrees Celsius to as much as 42 degrees. There is also an automatic fire extinguishing system which can be triggered from the interior or exterior. The turret for the TAM was what took Thyssen-Henschel the longest to design and develop, as it was a new element. A simple glance at it demonstrates the heavy influence of the Leopard 1 and 2 on the design, combining 2 elements, low silhouette and ample internal volume. It is shaped as a frustum, and, like the hull, is made out of sheets of electrically welded nickel-chromium molybdenum steel. The front of it is 50 mm thick, the sides 22 mm, and the rear and top 7 mm. All of it is at a 32-degree angle. Full turret traverse takes 15 seconds. The top of the turret houses several mechanisms. At the front right, the gunner's gyro-stabilized panoramic periscope, behind which is the commander's own Peri-RTA periscope. On the opposite side to the latter is the loader's periscope. Behind the commander and loader's periscopes were their respective hatches. The commander's hatch, serving as a cupola, has an anti-aircraft machine gun on it. The commander's cupola has 8 angular periscopes. The rear of the turret housed the electrical unit for the commander's periscope, which could be accessed from the exterior. On the rear of the left side wall, at the same height as the loader's hatch, was another hatch for which to insert ammunition, but, more importantly, eject spent shells. Each side has 4 Wegmann 77mm smoke launchers. Initially, the TAM was equipped with the rifled Rheinmetall RH-1 105mm gun, a German variant of the British Royal Ordnance L7A1. However, this was deemed insufficient, and Argentina upgraded it to the more modern FM K4 Modelo 1L, similarly rifled, itself also a licensed production of the L7, in this case built in Argentina by Rio Tercero. The whole gun weighs 2,350 kilograms, and the barrel is made out of one forged steel piece. There is no muzzle brake on the barrel, but rather a bore evacuator in the middle. The gun has a maximum depression of -7 degrees and a maximum elevation of +18 degrees, a somewhat limited arc of fire and the consequence of having the turret so far back. Maximum effective range when firing is 2,500 meters. The rate of fire for the TAM is 10 rounds per minute. The recoil distance is between 560 and 580 millimeters at a recoil force of 300 kilonewtons. In total, 50 rounds are carried, 20 in the turret and the remaining 30 in the hull. 13 of the turret rounds are carried on holding brackets for immediate use. The TAM carries 5 different types of rounds, all NATO standard. The fire control system on the TAM is quite austere to keep costs down. The main gun is stabilized with 4 gyroscopes, designed and built by Feinmechanische Werke Mainz. It operates via an electro-hydraulic system controlled by the gunner or commander, who also has the capacity to override priority over the gunner. Gunners on the TAM have at their disposal a TZF LA sight, designed and produced by Zeiss, weighing 40 kilograms and 1,320 millimeters in length. It is situated on the gun mantlet to the right of the gun, with a 6,000 meter range laser rangefinder, which is stabilized with the gun and has a precision of up to ±5 meters. If the commander is firing the gun, he has an independently stabilized periscope that can align with the gunner's sight, aim the gun, or observe the surroundings. This is done with the commander's periscope, the Peri-RTA, also produced by Zeiss. Its control panel can be used instead of the ballistic computer, but only as a last resort. The ballistic computer in the TAM is a FLER-HG produced by AEG Telefunken, which makes calculations for firing the gun, considering the ammunition being used, distance to target, gun elevation, and other relevant factors. The ballistic computer is connected to the 4 gyroscopes that stabilize the main gun and the gunner's control panel. The fire control system has 3 modes: manual, electro-hydraulic, and stabilized. Secondary armament consists of a coaxial 7.62mm FN Mag 6040 machine gun and a 7.62mm FN Mag 1620 for anti-aircraft duties, placed on the commander's hatch, both of which are licensed produced in Argentina by Dirección General de Fabricaciones Militares. The machine guns have a 1,200 meter range and are able to fire between 600 and 1,000 rounds per minute. Between the hull and turret, 5,000 rounds for the machine guns are carried. Inside the TAM, 8 hand grenades are also carried. Each side of the turret has 4 Wegmann 77mm launchers, which can launch anti-personnel grenades or more conventional smoke grenades, the latter creating a smoke screen 200 meters wide, 40 meters deep, and between 8 and 20 meters high. The vehicle's light weight means that there is a substantial recoil from the powerful gun. A solution to these issues can be found in the original suspension and running gear of the Marder 1, which consisted of a torsion bar type suspension with 6 dual-tired road wheels and 3 return rollers on each side. The first, second, fifth, and 6th road wheel stations had hydraulic shock dampers which absorb a significant part of the stress created by firing the main gun. The tracks are of a Vickers system, each track consisting of 91 links with rubber tank treads. These can be substituted by snow cleats if required. The interior of the TAM is divided into 2 main sections, with the frontal section being further subdivided into 2 subsections. The bigger of these subsections, occupying 2/3 of the space, houses the engine, whilst the smaller one is for the driver and driving mechanisms to his left. The driver has a hatch above his position, and the whole section of the frontal hull covering the engine can be opened for engine maintenance. The bigger rear section occupies the central and rear part of the tank and houses the combat area and turret basket, with the commander, gunner, and loader sitting on folding seats in this area, along with all the ammunition. At the rear of the vehicle, there is a small door for the crew to enter and exit and to replenish ammunition and other things the tank may need. Communications are by means of very high frequency SAL, SAM-180 and SAM-190 systems, and a SAL, SAM-170 radio receptor. For communication between the different crew members, each has intercom headphones and a telephone to communicate externally. Mobility was one of the most important aspects considered by the General Staff when setting the TAM requirements. The engine on the TAM is the MTU MB 833 KA500 diesel engine, a 6-cylinder rated at 720 horsepower at 2,200 to 2,400 revolutions per minute, and with a power-to-weight ratio of 24 horsepower per ton. The engine is kept cool by 2 ventilators at its rear, powered by a 33 horsepower engine of their own. The gearbox on the TAM is the HSWL 204 automatic planetary gearbox with torque converter and 4 forward, 4 reverse gear ratios. The first 3 are epicyclic gear trains, also known as planetary gears, and the 4th is a clutch disc. The maximum road speed is a very impressive 75 km per hour forwards and backwards. Off-road or cross-country speed was limited to 40 km per hour. The maximum range is limited to 590 km, but this can be increased by 350 km to a total of 840 km with additional fuel tanks. The fuel capacity inside the tank is a meager 650 liters. But with the addition of 2 200-liter fuel tanks on the back of the tank, this can be extended to over 1,000 liters. Among other performance indicators, the TAM can overcome 60% gradients, 30% side slopes, 1 meter tall obstacles, and 2.9 meter trenches. When it comes to fording, it is capable of fording 1.5 meter deep waters without preparation, increased to 2 meters with preparation, and 4 meters with a snorkel, which takes 45 minutes to set. While it is uncommon for TAMs to be equipped with one, all vehicles in the TAM family can carry an Israeli-built RKM mine roller for mine-clearing duties. However, this task would more likely be given to a VCTP or, especially, a VCTM. One of the TAM's main disadvantages resulting from its small size is its meager fuel capacity. Argentina is a large country with extensive plains and a long border with its potential adversary, Chile. Therefore, an Argentine tank needs a good road or rail network and an extensive operative range. The TAM has just a 650-liter fuel capacity, so this is extended by additional fuel tanks carried on the TAM's rear. These are not standard, and there are many variations. There are 2 types of fuel tanks, 200 liters and 175 liters, and tanks carry either 1 or 2, or, as already stated, none at all. When production began in April 1979, it was expected that 200 TAM and 312 VCTPs would be completed by April 1985, where the project was expected to terminate. However, economic difficulties meant that, in 1983, production was stopped at 150 TAMs and 100 VCTPs. Additionally, 70 unfinished vehicles were left in the factory. The first serial production vehicles left the factory in 1980. Having built the facilities and invested a considerable amount of money in them, but with production terminated, it was decided to try to find success in exporting both types of vehicles. However, several deals with Arab and Latin American countries fell through, and to date, no vehicle has been exported. In the meantime, the Ejército Argentino incorporated 20 TAM and 26 VCTP which had been built for export. During the 1982 Falklands War, the recently introduced service TAM were deployed to the southern region of the country to deter a potential invasion by British forces. Although the TAMs were never used for their intended purpose, they were kept busy by the multiple military coup attempts which shook Argentina between 1987 and 1990. In the third attempt, between December 1st and 5th, 1988, TAMs were used by the loyal government forces to break the siege at Villa Martelli, where the uprising was strongest, and detained the leaders of the uprising. In the last of this series of coups, on December 3rd, 1990, rebellious forces under Captain Gustavo Bray de Obeid took over a series of military installations, among them Tamse. The officer who took the factory, Colonel Jorge Alberto Romero Mundani, ordered 9 or 10 TAMs in the factory to head to Buenos Aires. En route, the tanks ran over a group of civilians, killing 5 of them before heading off to Mercedes. Seeing that the attempted coup was heading for failure, Romero Mundani committed suicide, one of 8 military casualties of the failed coup. In 1994, after an effort from the Ministry of Defense, TAMSE was repurposed to build a total of 120 vehicles, TAM and VCTP, to phase out older equipment, among them Sherman repotenciados. According to Mazarasa, by 1995, there were a total of 200 TAMs. During this period, other variants of the TAM family were built. Total production numbers are often cited at 231, but the exact number is far from clear. After a few more years of negligence, the Argentine company Champion SA worked on a series of maintenance and modernization programs on the TAM in the early 2000s. The TAM of the Ejército Argentino are divided among 6 tank regiments in 2 brigades. The first is the Premier Brigada Blindada Brigadier General Martin Rodriguez, based in the Buenos Aires province. This is composed of the Regimiento de Caballería de Tanques 2, Lancheros General Paz, the Regimiento de Caballería de Tanques 8, Cazadores General Necochea, and the Regimiento de Caballería de Tanques D, Husares de Pueyrredón. The second one is the Segunda Brigada Blindado General Justo José de Urquiza, based in Entre Rios province on the Uruguayan border. This is composed of the Regimiento de Caballería de Tanques 1, Coronel Brandsen, the Regimiento de Caballería de Tanques 6, Blandengues, and the Regimiento de Caballería de Tanques 7, Coracheros Coronel Ramón Estomba. Each regiment is equipped with 3 squadrons of 13 tanks each, subdivided into 3 sections of 4 vehicles plus an additional command vehicle. All things considered, the TAM is a product of its time, a late 70s tank based on mostly 1960s technology, and so it has become seriously outdated. When first introduced, the tanks equipping the armies of its neighbors were the M41 Walker Bulldog and M51 Sherman, for Brazil and Chile respectively. At this point, the TAM could claim to be the most advanced tank of the region. However, by the late 90s, Brazil had the M60A3 and would go on to purchase the Leopard 1A5, and Chile had several variants of the AMX-30 and Leopard 1V. By this point, the TAM was lagging behind its regional rivals and was in desperate need of modernization. In 2002, the Argentinian military and political authorities decided that it was a matter of urgency to reorganize the military-industrial capacity. In a document titled Simposio sobre la investigación y producción para la defensa, a project for the modernization of the TAM and other TAM-based vehicles was outlined in a project designated TAM S21, the TAM for the 21st century. The Argentinian company Champion SA was put in charge of this modernization project. Due to the closure of TAMZE, many TAM had fallen into a state of disrepair, and repairs were being carried out in regimental and battalion workshops. The initial projections were for 20 TAM to be maintained and modernized each year. 4 different features were to be modernized. The fire control system was meant to make the TAM able to perform and fire in all weather conditions and times of day, and a thermal sight was to be installed. The selected model was Israeli and was built in Argentina by Chitefa. Fitted to the right of the main gun, it significantly increased the TAM's range, being able to detect enemy targets at 7 kilometers, recognize them at 2.8 kilometers, and identify them at 1.6 kilometers. Curiously, the improved TH-301 by Thyssen-Henschel was equipped with a thermal sight from the very beginning. Another addition was a device for stationary battery maintenance, for improved performance of the tank's batteries by extending their lifespan, and GPS by the incorporation of a Garmin 12 GPS and outside antenna. The initial projection for 20 vehicles was reduced to 18, before the project was cancelled after only 6 vehicles had been modified, 3 per regiment of the 1st Brigade. By the mid-2000s, the age and obsolescence of the TAM was beginning to be a major concern for the Argentinian political and military authorities, who set out several plans to bring the main battle tank of the Argentinian forces up to date. This was especially a concern when Chile, historically Argentina's major rival, acquired Leopard 2A4s in 2007. There were 2 options, either modernize the TAM or acquire a new vehicle. With the second option, the M1 Abrams, Challenger 2, Leclerc, Merkava Mach 1 and T90 were all considered, and the plan was to buy 231 tanks and allow technology transfer. With an estimated cost per unit of over $8 million for a new tank, the modernization option became financially the most viable, with a unit cost of around $3,400,000. The General Staff laid out the requirements in 2010 in a document titled Documento de Requerimiento Operacional, stipulating many compulsory requirements, most of which were intended to increase the TAM's lethality by modernizing and improving the tank's fire control system and gun stabilization. There were several optional and preferable requirements, including improved armor and more modern communication systems, among others. 3 foreign companies put in bids for the TAM's modernization: Carl Zeiss Optronics with ESW GmbH, Elbit Systems, and Rheinmetall with ESW GmbH. Elbit Systems was the cheapest option and was given a contract at some point between 2010 and 2011, with the initial plan for the modernization of 1 prototype vehicle and 108 serial vehicles, almost half of the total TAMs in service, for a total of $133,460,000. In March 2013, the first prototype was presented. Some of the principal characteristics on this vehicle, not present on the TAM, were all-round vision for the commander and gunner with the addition of a commander open architecture panoramic sight, all-round vision for the driver, automatic target tracking, auxiliary power unit allowing the TAM's mechanisms to work without the need of the engine being on, Elbit laser threat detection system, digitization of the firing control system, electric drive for azimuthal rotation of turret and barrel elevation instead of the old hydraulic system, battle management and state-of-the-art communications and intercom equipment, automatic fire suppression system in the fighting compartment, thermal sleeve on the FM K4 Modello 1L main armament, and the addition of side skirts for increased protection. In short, the modifications were mainly in the fire control system, in an attempt to bring the TAM closer to modern standards. Despite 1 prototype being satisfactorily presented, the project with Elbit Systems did not go ahead. However, on June 26, 2015, the project was revived when the Argentinian government, now under the leadership of Mauricio Macri, reached an agreement with the Israeli government for the modernization of 74 TAM, along the lines presented by Elbit 2 years previously, with some extra additions, such as the substitution of the FLER-HG analog ballistic computer with a digital one. In March 2019, Minister of Defense Oscar Aguad highlighted the fact that the modernization of half the TAM fleet to the TAM-2C standard would prolong the TAM's service life for another 20 years. However, as of March 2020, only one tank has been fully modernized. The latest communications from Argentinian state officials suggest that the modernization is going to be cancelled, and instead, Argentina will look into substituting the TAM with a wheeled vehicle. At the same time as the TAM-2C project stalled, in May 2016, Argentina presented a new modernization pack for the TAM-2IP. Whilst the TAM-2C was an improvement in the fire control system and general performance of the TAM-2IP was intended to overcome one of the TAM's greatest weaknesses, its armor. Fulfilling the General Staff's initial requirements in the mid-70s, the TAM was light and fast, which was achieved with thin armor, 50mm at its thickest. The TAM-2IP was designed by the state-owned Israeli Army Systems. This project presumably originated following the TAM-2C negotiations between the Argentinian and Israeli governments in June 2015. The main improvement was the addition of an add-on armor kit all along the hull and the front and sides of the turret. Side skirts were also added. It is unclear if the upgrades from the TAM-2C were also continued on the TAM-2IP. As far as can be established, only the one prototype of the TAM-2IP was ever built, and was mainly used to test and evaluate the possibilities of add-on armor on the TAM. Having invested large amounts of money into the development of the facilities for assembling the TAM, but with production for the Argentinian Army finished, the state-owned TAMSE was an expensive asset funded by the state. So it was decided that rather than waste the facility and run at a loss, the TAM should be offered for export. Several countries were interested, and Peru and Ecuador even trialed it. Several other countries allegedly negotiated or showed interest in the tank, but sources are inconsistent and vague. As things stand, no other country apart from Argentina uses the TAM or any of its derivatives. In mid-1983, Peru made an effort to purchase 100 TAMSE vehicles, TAMs and VCTPs. However, financial reasons meant that they would cancel the order and stick with the T-54s and T-55s already in service. The 20 TAM and 26 VCTP, which had already been built for the delivery, were cancelled and transferred to the Argentinian Army. In 1984, Panama ordered 60 vehicles, again divided between the TAM and VCTP. However, this would not materialize. It is possible that the sources about this are incorrect and the tanks for Panama were actually for Iran. In the mid-80s, an ambitious order was allegedly placed by Iran for 100 TAM, or even as many as 1,000, which seems extremely disproportionate, and these numbers and dates seem confused. What is known is that in 1983, Diego Paleros, whose company Agrometal was based in Panama, offered to act as an intermediary between TAMSE and Iran in an operation worth $90 million for the purchase of 60 TAMs. Paleros himself may have been in line for a $9 million commission. In 1984, the Argentinian government tried to alter the deal, which prompted the Iranian delegation to cancel the purchase. Presumably, the use of an intermediary would have been because West Germany would not have sanctioned the selling of West German technology and components to Iran. Rumors that as many as 10 TAMs made their way to Iran are most likely untrue. The closest Argentina got to selling the TAM was to Ecuador in 1988-1989. Ecuador was looking for a tank for its armed forces and had a competition between different tanks to inform and determine their decision. The TAM's competitors were the Austrian SK-105, the American Stingray, and the French AMX-13. The TAM was the comfortable winner, scoring 950 out of 1,000 points. The deal was going to be for the purchase of 75 vehicles, split between TAMs, VCTPs, and VCRTs, for $108 million, but fell through, according to Sigal-Fagliani, because of the threatened closure of TAMSE. In the end, Ecuador did not purchase any tanks. Allegedly, during a tour of the Middle East in 1990, an Argentinian delegation offered the TAM to different countries of the region. Saudi Arabia was in line to make an offer for 400 tanks, and went as far as extensively testing a vehicle. However, no purchase was ever made, and there are two versions of the event. The first is that Israel protested to Germany that German technology was being sold to Saudi Arabia, and Germany blocked the transfer. This seems very unlikely, as Germany sold a number of TPZ Fuchs armored personnel carriers to Saudi Arabia in 1991 without any Israeli protests. The second is that the USA, which had Saudi Arabia as a traditional weapons customer, did not want competition. In the same period, the USA was negotiating a deal worth $1.5 billion, including investments in the Saudi arms industry and Saudi production of some components for the M1A2 Abrams. This latter explanation is the most likely reason why Saudi Arabia did not purchase the TAM, but it is hard to determine if they were even interested in buying the TAM in the first place. On this same tour, another potential customer was Kuwait, who, again, allegedly was interested in acquiring 200 tanks. A TAM was tested in Kuwait, where it impressed with its ability to overcome gradients and was required to fire 400 consecutive shots, which it achieved. Regardless, Kuwait did not end up purchasing the TAM and bought 149 M84s from Yugoslavia instead. It is unclear how much truth there is in the negotiations to sell the TAM to Saudi Arabia and Kuwait. However, it is known for certain that the government of Carlos Menem did make an effort to sell the TAM in the Middle East. In 1998, when being tried for his involvement in selling weapons contraband to Ecuador and Croatia in the mid-90s, as both nations were involved in wars at the time, the former Ministry of Defense, Oscar Camillon, admitted that the Argentinian government had used the Syrian arms trafficker Monzer Alcazar to sell the TAM to the Middle East. Just before the Gulf War, a relative of the Sheikh of Abu Dhabi supposedly visited Argentina with the intention of purchasing weapons. Whilst convinced by the TAM, he requested some modifications so it could carry 4 to 6 troops. Roberto Ferreiro, a senior engineer at TAMSE, was put in charge of carrying out these modifications, which were achieved by installing a bench from the VCTP instead of the electric batteries and the ammunition racks. This would have meant that the TAM's ammunition capacity would have been severely reduced. In the end, no order was placed and the modified TAM was put back in its normal configuration. Some of the sources regarding the TAM purchase by the United Arab Emirates are inconsistent, and it is possible that these negotiations were actually with Kuwait. There are other alleged potential customers of the TAM for which information is very limited. In Bartrones' thesis, he claims Iraq was interested in purchasing 400 TAMs in the early 80s, but international pressure made the deal impossible. According to Sigal-Fagliani, in early 1986, TAMSE contacted Libya to try to sell the TAM, but were unsuccessful. Chicalesi and Rivas state that the TAM was exhibited and tested by Malaysia. No other source mentions Malaysia apart from Wikipedia in English, which claims the Southeast Asian country signed a contract for 102 vehicles of the TAM family, including the TAM, VCTP, and VCRT. This seems very unlikely, as it goes on to claim that the PT-91 Tardy was acquired instead, which is completely untrue as this purchase was not done until the mid-2000s. In 1993, Admiral Fausto Lopez, with the knowledge of the Argentinian government, offered the TAMSE installations and 500 vehicles to Taiwan, an offer which was not accepted by Taiwan. One of the most distinguishing factors of the TAM is how flexible a platform it is. having spawned several derivatives, including recovery vehicles, self-propelled guns, and mortar carriers. Whilst this flexibility was not one of the initial requirements set by the General Staff, it was very much appreciated, and was in line with the initial wishes of the Argentinian military authorities to reduce or limit the reliance on foreign vehicles. Hardly a derivative, the VCTP is an infantry fighting vehicle and personnel carrier developed alongside the TAM by Thyssen-Henschel. Very similar to the Marder 1, on which it was based, it is equipped with a 20mm Oerlikon KAD-18 automatic cannon in a turret and can transport 10 troops. 124 vehicles have been built, with a number seeing service in Bosnia and Croatia as part of UN Pro 4 peacekeeping forces. Produced from the 1980s onwards, the VCT-M was the first TAM family vehicle to have been designed in Argentina. Eliminating the turret of a VCTP, it carries a 120mm Brandt MO 120 RT mortar, which fires through the hole where the turret once stood. 36 VCT-Ms have been built and are still in service. A variant of the VCTP developed in 1982, the VCPC is a command vehicle which substitutes the turret of the VCTP for a hatch for the commander. It has additional radio and communication systems and a map table in the middle of the vehicle. Only 9 have been built. One of the most adventurous derivatives, development for the VCA began in 1983, though production would not start until 1990. Designed to overcome a dependence on towed artillery, the VCA is an elongated TAM chassis where the main turret is substituted by one designed by Otto Melara. Equipped with a powerful Palmaria 155mm gun, 20 VCAs have been built and are in service. With a limited load capacity and the weight of its ammunition, the VCA was found to be impractical in some aspects. Thus, in 2002, a vehicle to transport and load the VCA's ammunition was built. Only 2 VC Anon have been built to date. Due to these low numbers, M548A1s are used in a similar fashion. 2 identical vehicles, derived from the VCTP, were built for artillery fire control in the mid-90s. The difference between them comes down to their roles. Whereas the VCCDF is used by artillery groups, the VCCDT is used at battery level. Built in small numbers, there are 2 VCCDFs and 4 VCCDTs. Originally envisioned in 1982 for the support and recovery of TAM and VCTM equipped units, the VCRT has a long crane, a winch, an auxiliary winch, and a dozer blade. Only 1 was built, and it is still in service. The VCLC was developed in 1986 at the request of the General Staff to have an armored vehicle equipped with rocket launchers. Originally intended to have 2 versions equipped with light CAL-160 rockets or medium CAM-350 rockets, only a prototype for the light version was built. Budget limitations meant that this example, which survives to this day as a static display, is the only one. 2 different derivatives were manufactured to fulfill the role of an armored ambulance. The VCA was developed in the 80s and is a turretless VCTP with internal modifications to carry stretchers. Several VCTP retained the turret but had their armament taken away. One mock-up, VC-AMB, was built in 2001, sharing a chassis with the VC-Anon, but not even a prototype was built. It is unclear when the Tanque Argentino Pesado was envisioned, but it is possible that it dates as far back as the early to mid-80s. Using the elongated TAM chassis as on the VCA, its main armament was a 120mm gun in a Leopard 2-like turret. No prototypes were built and there is very little trace of a design. The VCDA was a TAM derivative designed for air defense and would have been equipped with twin 35mm guns. Almost no details exist about this derivative. The VCLM was to be a TAM derivative intended to launch surface-to-air missiles. Roland or locally designed Halcon missiles were considered. Almost no details exist about this derivative. The VCLP was to be the Armored Vehicle Launched Bridge derivative of the TAM. Again, hardly any details exist about this derivative. The TAM has become a piece of Argentinian folklore and a source of pride. Although claims that it is an indigenous tank are untrue, the TAM has hugely benefited Argentinian industry and limited the dependence on foreign suppliers to equip its armed forces. When first introduced in 1980-1981, the TAM was a decent tank, packing a strong punch with its 105mm main armament and a mesmerizing speed and mobility which would have served it well along the vast Argentinian plains. Put simply, at the time, in the region, it was unrivaled. However, financial difficulties meant that the TAM was never built in the numbers intended, and the failure to export it doomed any further progress on the tank. By the 1990s, the TAM's age, and more importantly the technology it was based on, meant that other nations in the region had caught up or surpassed Argentina and the TAM. This is even more accentuated the further we go into the new millennium. Modernization programs, as sound and well-intended as they may have been stuck by Argentina constantly being held back due to a lack of liquidity and corruption. Taking this into consideration, a 20-year prolongation of the TAM may not be what Argentina's armored forces necessarily need, and issues such as weak armor are never going to be fully resolved. The time may be coming to bid farewell to the TAM and find a more suitable replacement for the Argentina of the 21st century. This was all for this video. Make sure to follow and subscribe, and also check out our website. We'll be releasing new articles on the regular. You can follow us on Facebook, Twitter, Instagram, or Reddit. If you use Discord, there's a link to our community server in the description. And if you would like to help us continue to develop and expand, consider donating on Patreon or PayPal. All of the funds will be used to help us improve and design new articles and features for you. Until next time, keep us in your sights.